Hello everyone, I'm Big Joy on Earth. In 1789, the chemist Lavoisier published a list of 33 chemical elements. Today, our periodic table contains 118 elements, with the first 94 found in nature and the latter 24 synthesized in laboratories. Without him, perhaps there ought to be much rejoicing. Here's a list of the first 32 elements from the periodic table, including their names, some properties, and common occurrences. The first one is hydrogen, the lightest element, colorless, odorless gas, a major component of water and organic compounds, used as fuel in rocket propellants and in fuel cells like those being developed by Toyota for hydrogen fuel cells. The second is the helium, colorless, odorless, with stable properties, common in helium balloons, safer than hydrogen balloons because it is non-flammable. Used in lightning due its high brightness and in cooling systems. Deep sea breathing mixtures for its inert properties, preventing oxygen toxicity. The third is lithium, a soft silver-white metal with strong reactivity, used in lithium batteries and some medications for uh, psychiatric treatments due to its chemical properties. The fourth is beryllium, hard, lightweight, with a high melting point, found in emerald and in aerospace materials, as well as X-ray windows and spacecraft structure components due to its physical properties. The fifth is boron, hard, semiconductive Semiconductors partially conduct electricity under certain conditions, like temperature changes. Boron strengthens glass and is used in the semiconductor industry. The sixth is carbon, known for its allotropes, including diamonds and graphite. Essential for biological molecules, fossil fuels, and applications like jelly and fuel. The seventh is nitrogen, colorless, odorless, tasteless, making up 78% of the Earth's atmosphere, key in ammonia and proteins used in fertilizer, used in fertilizers for promoting leaf growth and in industrial gases. The eighth is oxygen, supports combustion necessary for biological respiration present in water and involved in oxidation reactions like rusting, which doesn't affect gold and silver due to their stability. Ninth is fluorine, the most reactive non-metal, corrosive, present in refrigerants, toothpaste, and non-stick cookware, named partly after its presence in compounds like fluorite. The tenth is neon, a real gas, colorless, odorless, tasteless, used in knowing signs and high voltage indicators due to its scarcity and unique properties. The 11th is sodium, soft metal, reacts explosively with water, common in table salt, and used in food seasoning and high-intensity street lighting. The 12th is magnesium, a light metal that burns with a bright white light, used in fireworks, aircraft construction, and at early notebook computer casings due to its lightness. The 13th, aluminum, lightweight, corrosion resistant, found in beverage cans, constructions, materials, and packaging. Recyclable with applications in transportation and electronics due to its properties. Yeah, it's cheap. 14th, silicon, a semiconductor material common in electronics, glass, and solar panels, used in chips and solar energy applications due to its semiconductive nature. The 15th, phosphorus, vital for life, present in DNA and used extensively as fertilizer and in phosphorescent materials involved in nature phenomena like will-o'-the-wisps due to its release from decaying organic matter. The 16th, sulfur, yellow crystals, flammable, used in sulfuric acid, and gunpowder, fertilizers, and some medicines due to its chemical properties. The 17th, chlorine, a yellow-green gas with a strong odor used in disinfectants, hydrochloric acid, and water purification treatments. Chlorine gas can be produced through simple chemical reactions. Salt with salt acid and heat them together, then you can get a chlorine gas. 18th, argon, a real inert gas used as a protective atmosphere in metal welding and in lighting due to its stability and inertness. 19th, potassium, a soft metal that reacts violently with water, used in fertilizers and some medicines. Important in agriculture and medical industries for its reactive properties. 20th, calcium, essential for biological structures like bones and teeth, used in supplements, construction materials, and possibly in cement and concrete. 21. Scandium, a round metal with special chemical and physical properties used in alloys, electronics, ceramics, and aerospace and electronic industries for its strength-enhancing qualities. 22nd, titanium, known for its strength, low density, and corrosion resistance, used in aerospace materials and medical implants. 23rd, vanadium, hard, brittle, heat resistant, used in steel alloys and as a catalyst to improve the strength of steel and in chemical applications. 24th, chromium, enhances steel's hardness and corrosion resistance, found in stainless steel and coatings for its protective qualities. 25th, manganese, a hard metal that increases the toughness of steel, used in alloy steels and in batteries. 26, iron, the most familiar metal, magnetic, commonly used in construction and industrial machinery, integral to steel manufacturing and present in magnetic materials. 27th, cobalt, a hard magnetic metal used in magnets, alloys, batteries, and magnetic materials. 28th, nickel, a hard ductile metal used in stainless steel, batteries, and coins for its resilience and conductivity. 29th, copper, a red-brown metal with excellent electrical and thermal conductivity, used in wiring, plumbing, and as a germicidal agent on surfaces, despite potential health impacts. 13th, zinc, a blue-white metal resistant to corrosion used in coating to prevent rust, and in batteries. 31st, gallium, a soft metal with a low melting point used in LEDs, high-temperature thermometers due to its semiconducting properties. 32nd, germanium, a metalloid semiconductor used in fiber optics, electronic devices, and infrared optics. 33. The document then discusses the 33rd element, which is actually element number 81st, thallium, described as a soft, free white metal with high density and a low melting point. Thallium and its compounds are highly toxic and used in electronics, medical imaging, glass, and ceramics manufacturing. Its toxicity has led to strict limitations on its use due to several health risks, including permanent neurological damage, air loss, gastrointestinal diseases, and death. The document concludes, yes, this table concludes almost uh, over 100 elements which could be found in nature and which could not. There is a sad story about thallium toxic in China, in at the University of Tsinghua. The victim's name is Zhu Ling, who has already passed away. Bless her in heaven. Thank you all.